The mechanical braking is there. Mechanical braking. So mechanical braking is the simple example that the automobiles which are available, okay, either two-wheeler or four-wheeler, okay. So, so when you are traveling, you generally apply brakes. You want to stop the vehicle, you generally apply brakes. So when you apply brakes, what do you expect is that the vehicle will stop. So what happened there actually? So that the kinetic energy which was there, it dissipate as heat or it dissipate. You cannot take the use of that. So that is one method of some more things are there in those, that there is a friction is there. Okay, there is a friction is there, and there's a lot of inertia will be there. Okay, so all these things are there in the mechanical braking. Mechanical braking. Okay, now what are these electrical braking methods? Okay, what are the electrical braking methods? So of course, this electrical braking, they are applicable only when there is motors are there. When there are motors are there, then only these methods are okay applicable. So we list out these methods. First one is okay, so plugging. Second one is regenerative braking. Third one is dynamic braking. These are the three braking methods. Now, as of now, we discussed about, I think we have come across regenerative braking. We have come across dynamic braking also. Last previous classes, we have come across even dynamic braking also. So first, I will just okay, revise this. That these two will revise. Then we'll go to the first one, that is the plugging. Okay. So what is regenerative braking? If you recall, what is regenerative braking? Regenerative braking in the sense what you do exactly there is the regenerative braking. So, for example, you are operating with a chopper. Say, for example, you are operating with a chopper. So, you are controlling the motor with the help of a chopper. Then, what do? You go for second quadrant. You will operate in second quadrant. You will operate the motor in second quadrant. First thing. So, what do you do in the second quadrant? What do you do in the second quadrant is that the motor is there. Okay, so of course, so what exactly you do, that we are discussing. Then how you do it depends. Chopper, you have one method, and uh, and of course you have some more methods. Phase control converters also there. Even in the phase control converters also, by changing the firing angle, you have the chance to reverse the current. Okay, um, I'm sure that you might have that in the power electronics course that there is one dual converter is there. Okay, the dual converter by operating the dual converter at certain firing angles. Okay, you can you can uh, you can make the current gets reversed. So some methods also there. So even choppers are there. Even phase control converters are there. Several, but in the regenerative braking right now, even though we come across chopper, even though we come across the dual converter and the phase control converter, right now, right now we will discuss that how do you make this regenerative braking actually. So how do you do this regenerative braking is that? So what is the logic behind here is that Okay, so we see. So you see the logic here. What is the logic behind this? So what you do is the regenerative braking is that uh, first thing is that the main intention of this method is that to collect power from motor. So how come you collect? First of all, why do you want to collect power? You want to collect power because if you collect power, then it's advantages that you are tapping power from some source, some kind of source or something like this. You are tapping some power. So when you tap some power, then the source will have more power, so that it can give to some other loads. So that's the purpose. That's the purpose. You can use purpose. That's the advantage. Okay. So you can collect power from the motor. Okay, that is the one thing. So this is not possible in case of mechanical braking. So regenerative braking, what you do is that first of all, when you require braking, that is when you want to slow down the vehicle, okay, or when you want to slow down the motor, then at that time what you do is that so slowing down is nothing but the braking. So out of these three methods, if you go for regenerative braking, that is slowing down the motor process, that is the braking. So if you go for this method, the advantage is that you can collect the power from the motor. So how come the power in the motor there? So how come the power in the motor there? Because I told you already that this motor has some inertia, it has stored some energy, so that energy you can collect. So rather than dissipating as well, you can collect that. So that is the source there. That is the point there where you can find out the power. Okay. So and then second thing is that how do you make this happen? How do you make this happen? Okay, of course this is nice idea, but how do you make this happen is that simple thing, that the simple logic is there. Power is multiplication of voltage into current. So any one of this is negative, then the power is negative. So when the power is negative, in the sense load gives the power to the source. When the power is positive, source gives the power to the load. So that's the logic. So here what you do is now you make the current reverse. So if you make the current reverse, then you can make the power negative. So when you make the power negative, then in the regenerative braking, you can slow down the motor. Simultaneously, you can collect the power from the motor. So these are the advantages you have in the regenerative braking. So how do you do this? Is that this already we have seen that, for example, if it is a chopper, then if it is a chopper, what is the advantage is that you have a second quadrant chopper is there. You have seen the circuit diagram last class itself. So using that chopper, you can collect power from the motor. So you can slow down, or you can stop the motor at the same time. You can collect the power. You can collect the power there. So that is the advantage of the regenerative braking. So how do you implement is that I told you already that implementation implementation either using the second quadrant chopper, if you are using chopper, or if you are using a phase controlled converter, then you have a dual converter. We have a dual converter. So I hope you might have remember the operation of the dual converter. It is a full converter is there, two full converters will be there. Okay, so then you control one at a time. Then you may have either the current is from source to the load, or load to the source. Okay, of course we'll discuss this dual converter also briefly. So first we will see now. So I'm just telling that how do you implement is that either using the chopper or using the dual converter, you can implement that. So what exactly you are doing there is that you reverse the current. So when you reverse the current here, the power becomes negative. When you reverse the current, the power becomes negative. So when the power is negative, the load gives the power back to the source. So so that is how you do that. So how you do what you do here, regenerative braking, what you do, you slow down the motor, you slow down the motor. Okay, how do you slow down the motor here first thing, because we are, that's the main thing we are discussing, how it gets slowed down here. So slowing down, so how it gets slowed down in the regenerative braking is that, see, we have seen this thing, power becomes negative. It means this motor gives the power back to the source. So when it is giving back to the it is giving energy back to the source, then the energy here will decrease or it will come down. So when the energy here coming down, in the sense the kinetic energy of the motor is coming down. So when the kinetic energy is coming down, when the kinetic energy is coming down, obviously the speed of the motor comes down. It means that's the braking. Okay, that's the braking. Okay, so now, so this is the thing. Okay, so in regenerative braking, what you do is that you slow down the motor. At the same time, you collect the power from the motor. So how it gets slowed down is that as you are collecting the power from the motor to the source, its kinetic energy decreases. So as its kinetic energy decreases, the motor parts, they lose this kinetic energy, okay, or they lose this mechanical energy. So automatically it slows down. So that is the procedure. And how do you implement that? Is that either using chopper or using the dual converter. So you have the methods of how do you implement this also. That's the reason. Now what is dynamic braking? What is dynamic braking is that we have seen this thing that last class. One example I will tell you that. So there is a circuit diagram. I will just recall that. This is RB will be there. There is RB will be there. Then here you have switch. Then here you have the motor. I will not draw entire thing. I will just simply put here motor. So here you have both R, L, E. All three are there. So the current here is in this direction. So this is the dynamic braking we have seen, whether it is series motor or whether it is separate like separate. This is the dynamic braking. When we close the switch here, what happens when we close the switch here is that the current flows through the switch. When we open the switch, the current flows through the R. So what is the advantage here? That there is one advantage, there is one disadvantage of here. Okay. So what is that thing is that the advantage part. The advantage part is that as we have an external resistance here RB, so the energy which is stored in the motor, okay, will dissipate in this RB. So you have R is there, L is there. So when the switch is open, in the closed path, what is the total resistance? R plus RB, whereas the inductance is LA. Okay, RA plus RB, LA. What is the time constant if you recall? The time constant is LA by RA plus RB. Now you see if as because of the presence of RB. For example, if you don't have RB, then LA by RA. So now LA by RA, LA by RA plus RB. If you compare, okay. So this time, which one? This LA by RA plus RB. When you have an external resistance, this time is lesser. This time is lesser. So time is lesser in the sense time constant is lesser in the sense what its response is decreasing or its response is increasing in lesser time. So here what you find out is that the energy which is stored in the motor will dissipate or it will dissipate in this resistor in lesser time. It means if the energy here dissipating in lesser time, okay, what is the advantage? That the response is fast. So you can something like that. The speed or the response, you can say the response. For example, you have applied brakes. So when you have applied brakes, what do you generally expect? You will expect that immediately the vehicle stops. So it means that this immediate word is there. So this is fastest response. So you expect the response to be very fast. You expect the response to be very fast. What is your action here? The action is to stop the vehicle. The action is to stop the vehicle. So the response should be the vehicle should be stopped. So this response will be fast. Why it's fast? Because the time constant is less. Why the time constant is less? Because we have added an extra resistance. So that is the advantage of this over the regenerative braking. What is the disadvantage is that What is the disadvantage? Now, where the energy is going in this case, in the dynamic braking, the energy in this dynamic braking is going as loss in RB. So dissipation in, it is dissipation in RB. It is dissipation in RB. So 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 as it is dissipation in RB, so the power which was there or the energy which was there, it is totally going as waste. That's the disadvantage. So you don't have any option here to collect. So dynamic braking, this is called dynamic braking. So in the dynamic braking, so it is also method of stopping the motor. Okay, dynamic braking is also. So how do you stop here? First thing, how do you stop is that you will connect an extra resistance here, like this. Okay, when you connect an extra resistance here, then what happens is that the energy which is there will dissipate. When the energy is getting dissipated, or the energy in the motor gets reduced, the kinetic energy in the motor gets reduced, then the speed of the motor obviously will get reduced. That's called braking. That's called braking. So this is how you implement that, and how it is different from the previous one, because you can make the response fast because of the decrement in the time constant. So the time will be less, so it gets reduced. So these two methods already we have seen, and with these methods we have got some equations also in the choppers and in the, yes, in the choppers, whether it is DC series motor or whether it is separately accelerated motor. Okay, both you have seen. Okay, so now we'll go to another method, that is plugging. So what you do in the plugging is that, so assume that, okay, we'll take one type of motor we'll take, uh, which motor I will take, separately accelerated DC motor, say for example, separately accelerated DC motor. So this is speed, this is torque. Now, what is the torque speed characteristics in the separately accelerated DC motor? I hope you might have remembered by this time, because several times we have gone through this. At least we have gone through this around 10 times. Okay, so this you will find out. Okay, so now it is in the first quadrant. Please remember now. It is in the motoring mode. So it is in the motoring mode. So you have seen that as the torque increases, you have seen the speed decreases. As the torque increases, you have seen the speed decrease. Now assume that you are operating at this point. Okay, now you are operating at this point. At this point, so it means you are running the machine you are running the DC machine, that is separately accelerated DC machine, as a motor here. So you are running as a motor here. So at this point it is motor. Now assume that this is the operating point. So at this point it has some speed, and it has some torque at this point. Okay, now what you do is, now in plugging, what you do here is that uh, you simply reverse the motor connection. It means the motor is there here, this is the motor. Okay, this is the motor is there. So you generally give plus minus. This is the voltage you give. Okay, this is how you give. Now, so when you give like this, now it is acting as a motor. So now you want to stop the motor, or you want to slow down the motor. Then what you do? You apply the braking. For example, if the braking method is plugging, then what is the procedure you follow is that you reverse these terminals, this one. So you reverse these terminals, and at the same time you connect a resistor in between this. So please see here. So first you reverse that. So you reverse this. So when you reverse this, what will happen now? Okay, so earlier it was plus minus. So as it was plus minus, okay. So you have seen this thing that I will show you here. One important thing, that you reverse the polarity of the voltage. See, I have reversed that. Earlier it was this top one is the positive and this one is negative. So now in between you connect a resistor once again. Say for example you do like this. So when you do like this, what will happen now? What will happen is that when you do like that, when you reverse this, when you reverse this, okay, so the current direction will get reversed. Obviously, the current has to get reversed. Maybe not immediately, but within some time, because you have connected a resistor, extra resistance you have connected here. So because of this extra resistance, the time constants it gets reduced. So we can expect this thing that the current will definitely get reversed. Of course, it may take some 1 second or something like this. Or it depends upon the value of LA by RA plus R. It depends upon this value. How many seconds or how many milliseconds depends upon that value. Okay. So you will expect that the current, as you reverse the voltage polarity, the current gets reversed. So when the current gets reversed, what do you find here? You can expect the torque gets reversed. You can expect the torque gets reversed. This is what exactly happens here. So the torque gets reversed. When the torque gets reversed, okay. So torque gets reversed in the sense what? Now the torque is positive. It's get reversed in the sense torque becomes negative because the current gets negative. So because this is a separately excited DC motor, so T proportional to IA. T proportional to IA. You reverse the IA, that is, you make the current negative. So the torque will definitely negative. So from this point, what will happen is that from this point, the operating point will shift to, it will shift like this. It will shift to second quadrant. So the operating point here earlier was here A, now it will go to B. So it will jump to B. Why it jumps to B? Of course, it may not be a sharp jump, but definitely it will go to this point. Why it goes to this point? Simple answer that why it goes to this point, because you have reversed the terminals here, so the current gets reversed, so the torque gets reversed. So torque gets reversed in the sense what now? The torque was here at point A, so the torque is positive here. So as the torque gets reversed in the sense torque becomes negative. So where do you find the negative torque? In the second quadrant. So this point will jump to the that point. This point will jump. So the speed here and the speed here more or less same. There won't be much change in the speed because of the inertia. What's next after this point? After this point, what's next? Now what is how the graph you will get? What will happen after this point? When it goes to the second quadrant and the torque gets negative, then see torque gets negative in the sense earlier it is having one particular torque. So because of that torque, your load is running in one particular direction. The load is running in one particular direction. Say for example clockwise direction. So the motor is running in the clockwise direction. Now you make the torque negative. It means what will happen now is that something like you are applying the force on this motor or on this load, okay, in the opposite direction. So in the opposite direction, now you apply the force because the torque becomes negative. It means negative torque in the sense, for example, positive torque is the clockwise direction. Then definitely negative torque. It means it applies force or it force it in the anti-clockwise direction. So it force it in the anti-clockwise direction. So then what you generally expect now when it force in the anti-clockwise direction? You will see that the speed slowly decreases. Okay, the speed slowly decreases, and at the same time, torque also gets reduced. Why the torque gets reduced here? Once again, you must understand here, because the torque gets reduced. Okay, it may not reduce. It may not reduce in proportion to your omega. Let me tell you one thing. It may reduce slowly, but the speed will reduce rapidly. So you will find out that from point B, the graph will come down like this. Okay, now you see I have shown you now here. So at this point, the speed is zero. At this point, the speed is zero. So then what do you now? Once the speed becomes zero, you disconnect the supply. If you don't disconnect the supply, what will happen now? It will continue in the opposite direction. So the speed becomes negative. So it will enter into third quadrant, something like this. So what is your job here is that once the speed becomes zero or nearly becomes zero, then you turn off this supply. So that's the procedure how you do in the plugging. So what you do in the plugging method is that you first of all you reverse the voltage polarity, and in between that you put a resistor. So if you do that, what is the advantage you find out is that the current gets reversed, so the torque becomes negative. When the torque becomes negative, obviously it is applying a force in the opposite direction onto the motor, so the motor speed slowly decreases. So first it decreases, then after that it reverses, it goes in the opposite direction. That is the thing which will happen, because when you reverse the terminals of any motor, then what do you expect generally? First of all, the speed of the motor will come to the zero. Then after that, it accelerates in the opposite direction. So before it accelerates in the opposite direction, you disconnect the supply. That's it. So you have stopped the motor like this. This is how it happens. So these are the three methods of electrical braking. I hope you might have known by this time. Okay. So I just revised what is there in that. Okay. So then we'll go to another topic. We'll go to the topic of dual converter. I'm sure one thing I will tell you. This you might have got in the power electronics course. Okay. So what is a dual converter? Is that it is a combination of two full converters. Okay. I hope you know what is a full converter, what it does. Okay. How it does all these things. I'm sure that you know. So we'll recall what is there in the full converter. Sorry, what is there in the dual converter. I told you already that dual converter has what it has. Dual converter. We'll just draw the circuit diagram with dual converter. It is nothing but two full converters. It's a combination of two full converters. Okay. So one full converter is here, this side. Okay. Now another full converter is here, this side. One thing you must understand the difference between these two full converters. What is the difference? The cathode is here upwards, whereas the anode is downwards. Whereas this full converter, anode is upwards, cathode is downwards. It means you are changing the direction of current. It's very important. You are changing the direction of current by reversing the switch configuration. By reversing the switch configuration, you are simply changing the direction of the current. That's the logic. Nothing else is there. That's the logic here. Okay, so here you give the supply. It is supply is there here. There is supply is there here. Here you have the motor. If I am not wrong, you might have remembered this inductance also. What is the purpose of this inductance? Is that what is the purpose of this inductor? That to limit the circulating currents. To limit the circulating currents, you have this inductor. Okay, I'm sure that you might have called this inductor as limiting current also. Okay, so limiting inductor, you call this as a limiting inductor. So what do you find out here is that, see, just a simple logic that you just look at this picture, you look at this picture. So if you look at this picture, this cathode is upwards and anode is downwards. Then what is the direction of the current generally? The direction of the current is always from anode to cathode. The direction of the current is always from anode to cathode. In a thyristor, the current flows always from anode to cathode. So this is the direction of the current. It means it flows upwards, then it takes this path, this direction. Whereas you see now, the anode is upwards, whereas the cathode is downwards. So you will find out the current flow downwards. That is from anode to cathode. So it means the current is flowing like this. So that's it. So you see here now. But what about the voltage? Voltage is positive. Here also positive. Total positive. Okay. So what you do exactly here is that you operate this converter one, full converter one, P1, FC2. You operate it for some firing angles. Okay. And for some duration or for some switching sequence, you operate full converter one. Then so when you operate the full converter one, when you want to have the current positive, that is from source to the load. That is from source to the load. When you want to have the current in this direction, of course the voltage is positive only. So that is when you want to run this motor. This is the motor, DC motor. When you want to run the DC motor in the motoring mode, you operate full converter one. When you want to operate in the regenerative braking, okay, then you operate full converter number 2. So that's it. That's the logic. There is no other logic there here. Simple logic is there. Okay. So because you see, when you operate full converter 2, the current, you see how it is flowing from load to the source. When you operate full converter 1, then the current flows from source to the load. but in both the cases, the voltage is positive itself. Okay, so the this is the purpose of the dual converter. Okay, because if you take one full converter, so in one full converter, the current is always in only one direction. Current is always in one direction. Okay, so but what is the other thing is that in full converter there is an option is there. You might have seen this thing that if the firing angle is greater than 90, if the firing angle of the full converter is greater than 90, if alpha is greater than 90, then you might have recalled this thing. We can recall this thing that the voltage becomes negative, that we have seen. The voltage becomes negative. So one full converter can make the voltage positive or it can make the voltage negative. Whereas another full converter also same thing. It makes the voltage positive or it makes the voltage negative. But what about the current? One full converter is the current is always from source to the load. The other full converter, the current is always from load to the source. So this is the simple operation of your dual converter. And see, let me tell you. So we just repeat this thing what I said. If alpha greater than zero, this E is negative. Okay. Okay. Alpha less than zero, E is less than 90 is positive. I'm sure that this you must have seen already. Okay. So then, so then, uh, then what is this ideal dual converter does? Ideal dual converter is that now we'll consider that this firing angle is alpha 1, whereas this firing angle is alpha 2. We just consider like this. Okay. So that we'll consider this as alpha 1, whereas we consider this as alpha 2. So in ideal dual converter, we might have seen since this is just a okay, just a rehearsal of or it's just a revision of the previous topic. Nothing is there, and I'm sure that you might have got this also. What is the EDC1 you got? What is EDC1 or what is E1? What is E2? Of course, you can find the EDC. So what is E1 you got? What is E2 you got? So there is output of the full converter. I told you already it is output of the full converter. So what is the formula you got if you recall? Just recall yourself. What is the formula you got? E1. E1 is equal. It is from the full converter number 1. So it is E max. E max in the sense the supply voltage here is there. For example, if I take this as E, then it has a maximum value E max cos alpha 1. This is the formula. Similarly, E2, what is the formula? E max cos alpha 2. That's it. So these are the two formulas. So equation, the voltage equation here, the voltage equation here is that E max cos alpha 1, E max cos alpha 2. That is for E1, E2. This is for E1 and this is E2. You see yourself. Whatever I said here, when alpha 1 less than 90, then first quadrant. So in the first quadrant, E1 is positive. You see here. You check yourself. Alpha 1 is, if it is greater than 90, then alpha greater than 90, then E1 is negative. We are sure that E1 is negative because cos is negative in the second quadrant. Okay. So this is what I said now. So any one full converter can make the voltage is either positive or negative. But remember, current is always positive. Positive in the sense from source to the load. Whereas the other full converter also same thing. Even E2 also same thing, that E2 is either positive or negative. It depends on what? It depends upon firing angle alpha 2. Here it depends upon firing angle alpha 1. But the current is always negative. So you see here now. So if the current is negative, that's what I said, that you can even use the dual converter for the regenerative braking or any all four. And condition here is that because there shouldn't be any kind of overlap actually. There should not be any kind of overlap. So what is the condition here is that alpha 1 plus alpha 2, whatever you do here, the sum should be equal to 180. This the reason also we have seen even the previous semester itself. Why you should make alpha 1 plus alpha 2 180 degrees. So if alpha 1 is 60, then alpha 2 should be 120 degrees. Okay. So 120 degrees in the sense in another cycle it enters. In another half cycle it enters. That's the meaning of that. Okay. So if alpha is so likewise, based upon the value of alpha 1, alpha 2, the sum should be equal to 180 degrees. So this condition also we have seen, and why it is so also we have seen. Okay. So now, what is the other thing we will do here is that to avoid some kind of to avoid some kind of uh, unwanted current flow. So what we generally do is that in between these two, in between these two, you will have a diodes. I'm sure that why do you have a diode here? So if you have a diode here, so you make the current unidirectional. You make the current totally unidirectional. So the full converter one, the full converter one, the full converter one. So you are forcing the full converter one to flow the current in only one direction because the diode cannot flow the current in opposite direction. Here also same thing, only one direction. It's the same as the previous picture, except you are adding a diode here. Then source is there, there is a source is there. Of course, you may have the closed loop here, so some controller will be there. So this controller will give the firing angle to this, and also it gives the firing angle to this. Okay. So how it gives the firing angle? What is the logic behind it? Is that alpha 1 plus alpha 2 is equal to 180 degrees. This is this is how you proceed here. Okay. So this way, even you can use the dual converter, not necessarily the full converter, even if not necessarily the chopper, even the dual converter also can do the same purpose because E is positive, E is negative. Current is positive, current is negative. In the sense, all the four possible combinations, first quadrant, second quadrant, third quadrant. All the things are also possible with the help of this dual converter also. Okay. So now you can consider yourself some kind of separate accelerator motor you can take, and series motor also you can take, and you can go ahead with that. Okay, we'll see that anything else is required.